Hello everyone, welcome to this video. In this video, we'll be starting with mixed questions from the chapter 9. Here, I urge you to practice these questions by yourself, then only you'll get to know how to perform such questions, how to solve such questions. Once you have completed your answer or you are stuck at some stake, then you can resume watching this video and continue with the questions. So let's start with the first example here. If Pth, Qth, Rth and Sth term, these four terms are given to be that in AP, right? They are the terms of an AP which are in GP. Now, this is a trickier statement which states that they form, suppose we have some AP. Let's take the first term of that AP to be small a and take the small d to be the common difference. Then in that case, you can write Pth, Qth, Rth and Sth term, right? These are the terms of some AP. So this Pth term, let's call that by a small subscript p. It would be a plus ap minus 1d. Why? Because the nth term is given by a plus n minus 1 times of d, right? Similarly, you may write the Qth term, you can write the Rth term, and you can write the Sth term, right? And you can mark them as equation 1, 2, 3 and 4. Right. Moreover, what we are given that all these four terms, they are a part of GP, right? They form GP. So that means their ratio is common, right? The ratio is the same. So that means AQ divided by AP, this thing is equal to AR divided by AQ, and this is further equal to AS divided by AR. So let's mark this as equation 5. Their ratio is constant, correct? Moreover, what we wanted to prove? We wanted to prove that P minus Q, Q minus R and R minus S, they are also in GP. So we need to prove that their ratio is constant. So we need to prove that Q upon this divided by this, Q minus R divided by P minus Q, that is equal to this R minus S divided by Q minus R. This is what we wanted to show. Let's mark this as equation 6. Furthermore, we will utilize this thing. Now you can see that we have two equalities here. So let's take first of all this pair. If we take this pair with us, then what are the terms? You can see what is the value of AQ. AQ is A plus Q minus 1D. AR is A plus R minus 1D. AP is A plus P minus 1D. And AQ is A plus Q minus 1D. So substituting the values here, and moreover, you know, if two fractions, they are equal to each other, then the difference of numerator divided by the difference of denominator is also equal to it. For example, let me take an example. 1 by 2, that is equal to 3 upon 6, right? So what is the difference? 1 minus 3 divided by 2 minus 6, it is minus 2 by minus 4, which is again 1 by 2. Let's take another example. 1 by 2 is equal to 4 by 8, right? In this case, 1 minus 4 divided by 2 minus 8, it is equal to minus 3 divided by minus 6, which is again 1 by 2. So you see, this thing is always true. You can check it generally also, correct? So we can use this result here, so that the difference of this and this divided by the difference of this and this is the same as these two ratios, correct? So both of them, they are equal to their differences. So you see A from here and A from here gets cancelled, A from here and A from here gets cancelled. So you are left with Q minus 1, right? You can take D as common, so you are left with Q minus 1 minus R plus 1, right? This thing, and divided by, again from these two terms you can take D as common, so you are left with P minus 1 minus Q minus 1. So it would be P minus 1 minus Q plus 1. So you see, this 1 and 1 gets cancelled, 1 and 1 gets cancelled, so you are left with Q minus R divided by P minus Q. So that means this thing is equal to this thing from which we have started, because we are saying the whole of this thing is equal to this ratio. Hence, let's mark this as equation number 7. Similarly, now we can take the second pair here. AR by AQ is equal to AS by AR. When we take this pair here, So in this case also we can do the same thing. We can subtract the numerators divided by subtract the denominators, then cancel out these terms here. Correct. Take out the common term d in both the terms. D and d gets cancelled. -1 plus 1 minus 1 plus 1 gets cancelled. So you're left with r minus 1 divided by q minus r. So you see all of this thing is equal to this thing. So let's mark this as equation 8. From equation 7 and 8 you can see you have AR upon AQ equal to Q minus R upon P minus Q. AR upon AQ is equal to R minus S upon Q minus R. So using these two equations, these two terms are equal to each other. If these two terms are equal to each other, what does it mean? It means that the three terms Q minus R, P minus Q and R minus S, they are in GP. Correct? And this is what we wanted to prove in this particular question. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.